Now here in this video we're going to look into the inverse trig properties, and we're going to start out looking at the sine function, which basically means if we had the sine of the arc sine. Okay, so here if we want to take the sine of the arc sine of x, then as long as we're in the right domain and range, this would simply be equal to x. Now what that means here is that our x is going to have to be between or anywhere from -1 to +1, because this goes back to looking at our domain and range. We talked about our sine function, how we had to restrict the domain and the range that we would have. So here, if we take the sine of the arc sine of some value x, then the sine and arc sine is going to cancel out, and you're simply going to get x as long as x is between -1 and 1. Now, of course, here notation-wise, we could write this as the sine as the inverse sine of x equals x. Okay, so again, notation-wise, this sine to the -1 and arc sine mean exactly the same thing. Now, what if we state this the other way around? If we take the arc sine of the sine of y, this will be equal to y as long as our y value is from where? Well, if you recall, we talked about the sine of y. Remember when I was drawing this unit circle type deal, and we said that the inverse sine or the arc sine is only going to give us answers from -pi/2 to a +pi/2. So that means here this y value has to go from a -pi/2 to a +pi/2. So as long as we're within this value here for the domain and a range, then arc sine of sine is simply equal to y. The sine arc sine of x is simply equal to x. All right. And then if we were to look at the other example, so if we go to the cosine, we would have the cosine of the arc cosine of x. And again, this would be simply equal to x as long as our x value is from -1 to +1. And then we could look at it as the arc cosine of y, the arc cosine of the cosine of y is equal to y as long as our y value is where? Now, it's not the -pi/2 to +pi/2. Remember, this is where we looked at the inverse cosine, and we said it went from 0 to pi. So here we're looking at this value of 0 to 1 pi. And then last, we have our tangent. So that means here, if we were to take the tangent of the arc tangent of x, this would certainly be equal to x as long as our x value here, now this one's a little different because you have to remember the tangent function's different. That means here x could actually be any real number, so -infinity to +infinity. And then if we look at it the other way, if we took the arc tangent of the tangent of y, this would simply be equal to y as long as our y value here, not a bracket, and this is where, remember, this is where I marked off on the circle, we're going from -pi/2 to a positive, to a +pi/2. But when we do this, we have an open circle. The endpoints are not included like they are up here for the sine function. So that means here the y value would be parentheses -pi/2 to a +pi/2. So as long as you're within these correct domain and range, then if you take the function of its inverse or vice versa, it's going to simply be equal to that value. So now we want to look at some examples applying these particular properties. And the first example that we want to look at is what happens if we have the sine of the inverse sine, so I'll use the inverse symbol here, or we could call this the arc sine. So this would be the same thing if I was to write sine of the arc sine of 0.12. Well, we have to think about this. If we look at up here, we have the sine of the arc sine. So it says if we have the sine of the arc sine of x, as long as our value here is in between -1 and 1, it's going to be that same value. So if we go down here, 0.12 is certainly between -1 and 1, right? So therefore, this is simply going to be equal to 0.12. And we can verify that with the calculator. If we go to the calculator, we could take the sine function, and then we want to go second sine. So we're taking the sine, the inverse sine of 0.12, and now we need to close the parentheses here, and then we need to close it a second time, and then we hit enter, and notice we get the same answer of 0.12. So as long as this number here, the 0.12, is within the right range here of -1 to 1, then that's going to simply be your answer. Now, what if we look at it the other direction? If we had the arc sine, let's say the sine of pi over 4, what is this going to be equal to? Well, once again, we need to make sure now, make sure you notice the difference here. When we have the arc sine of 0.12, this 0.12 is the ratio of our y value, arc sine is y, so this is the y over r, okay? And here when we say the sine of pi over 4, the pi over 4, this is our angle, okay? So if we have pi over 4, is that within negative pi over 2 and a positive pi over 2? And the answer is yes. So therefore, this is simply equal to pi over 4. And once again, we could verify that on the calculator by simply going to second sine, which is the arc sine, of the sine of pi divided by 4, and close our parentheses. Let's see, one more. And we get 0.7853. Well, let's see, if we were to take second pi divided by 4, that is pi divided by 4. So that verifies here that the arc sine of the sine of pi over 4 certainly does equal the pi over 4. And again, this is the idea where if you take the arc sine and the sine, they're going to cancel each other out. Or if we take the sine of the arc sine, they're going to cancel each other out as long as you're within the specified range here that's listed. All right, let's try another example. And this one here you're going to have to be careful with. So if we have the arc sine of the sine of 3 pi over 2, what does this equal? Well, here we have this 3 pi over 2. Well, if we go to the sine function, is 3 pi over 2 within this negative pi over 2 to positive pi over 2? So this here has to go from negative pi over 2 to a positive pi over 2. But we know if we look at that here, the angle would have to be somewhere in this region. But 3 pi over 2, where is that located? Well, 3 pi over 2 is actually located here. Okay, so 3 pi over 2 is much bigger than pi over 2, so that means here this answer is not going to be 3 pi over 2 because it's not within this range of negative pi over 2 to a positive pi over 2. So what does that mean? Well, at first you may say, well, there's no answer, there's no solution, but here there is a solution, it's just not 3 pi over 2. There's two ways that we can look at it. If we notice that 3 pi over 2 is actually right here at the, it's at the exact same location here as our negative pi over 2. So because they're at the same location, then that means our answer would be the negative pi over 2. Now, another way that we can calculate this is we can think of it this way. We can say, well, if we have the arc sine, what is the sine of 3 pi over 2? Well, we know the sine of 3 pi over 2. That means if we went here to the 3 pi over 2, our coordinate would be 0, negative 1. And the sine function is y, so that means we would have the arc sine of a negative 1. Well, what is the arc sine of a negative 1? Well, that means we look for where do we have a y value of negative 1, and that occurs right here, and we know that angle would be equal to a negative pi over 2, because the negative pi over 2 is what's within our range for an answer. So be careful. Even though you look at this and say, well, this 3 pi over 2 is not in the range, that just means when we take the arc sine of the sine of 3 pi over 2, the answer is not 3 pi over 2, but it's the angle that's at the same location that is within the range of negative pi over 2 to a positive pi over 2. Okay, and that's going to be the case for all of these. I'm kind of focusing right now on the sine function, but you would have the similar properties if you were looking at the cosine and arc cosine from 0 to pi, and then the tangent and arc tangent if you have all real numbers for the x, or for the y, negative pi over 2 to a positive pi over 2. Okay, let's take a look at one more example. If we have the cosine of the arc cosine of 6, what does this equal? Well, this is where we need to think about here, the arc cosine. Where does that have to be? Well, if we go up here, if we have, our cosine function here, the cosine of our arc cosine, if we look at, this is what we have, our x value has to be from negative 1 to 1. So if we go down here and look, this value here has to be from negative 1 to 1 in order to take the arc cosine. Now this is a little bit different because we're not able to take the arc cosine of this, so here your answer would simply be not possible. Okay, 6 is not in the domain. Okay, and again, the domain is, it's not within this domain of negative 1 to positive 1. And we can verify that with the calculator. If we were to take the cosine, second inverse cosine of 6, and if we hit enter, we get a domain error. Now again, that's not because we typed something in wrong. Sometimes that's the case, but in this case, there's a domain error because the 6 is not within the particular domain for the inverse cosine. Now let's go back here for a second to kind of verify. I meant to look at the calculator. What happens if we go back to this arc sine that we had, arc sine of the sine of 3 pi over 2? Well, let's put this in the calculator and see what happens. So if we go second sine, the sine of the 3 pi divided by 2, and notice here when I hit enter, we get a negative 1.57. So notice we didn't get 3 pi over 2, we got a negative 1.57, which happens to be, let's see, if we were to take a negative pi over 2, we get a negative 1.57. Because if we were to take 3 pi divided by 2, notice we get a completely different angle, completely different answer here. So notice the difference here. Your calculator is always going to give you the correct answer because it's as far as being within the domain. So notice your calculator gave us the answer of a negative 1.57, which is the negative pi over 2, which is within the range that we needed here. However, when we looked at this function, the 6 is not within the domain, so we can't even take the arc cosine of 6. So that's why this one is not possible. The reason the one up here with the 3 pi over 2 is possible is because we can take the sine of 3 pi over 2, which equals the negative 1. It's just that when we take the arc sine of a negative 1, it's going to be a negative pi over 2, not the 3 pi over 2. Okay, so hopefully now you understand this a little bit better with your inverse trig properties. So you'll notice here where it's important to understand for each one of these here, the sine, the cosine, and tangent, make sure you understand the idea of the domain and range of as far as your input and outputs.